Since we're only going to use 32-bit signed integer to string conversion, I'm actually going to remove this section right here from our code. Okay, so I'll just use this and continue our demonstration from this point on. Okay, so the next demo is conversion from Ascii input to double word, or conversion from text to an integer. Let's demonstrate how this is done. So supposedly when we ask the user to enter up to 10 characters right here, let's hope that this input that the user gives us is going to be a valid input format of an integer. So we can say that please enter an integer. Okay, so we have this integer prompt in our program, and we're going to ask the user to input an integer in valid format, and we're going to say input into this buffer. Remember, this is the input macro, so we're doing this input again, so it requires the length of the buffer. And so I'm just going to replace this 12 characters. Instead of hard-coded 12 in multiple places, I'm just going to use the length of the buffer to make it more look more generic. And here on the next line, this demo program is trying to convert the input in this buffer into 16-bit value in register AX. So I'm just going to change it to atod because I'm going to stick with 32-bit conversions. So what we do here is we're just going to replace A to I with A to D macro. Okay, so I'm just going to use this macro in place of this demonstration like this. Okay, all right. So we're going to convert whatever the input by the user was into 2's complement, which is a signed value, and the result is going to be an EAX. So this little sample right here is similar to what we do. Okay, so then the results of A to D, right? So Ascii to double word, that's the idea of this name A to D. Convert Ascii input or Ascii string of characters, potentially containing valid digits, converted to a value, 2's complement value, signed value in register EAX. All right, so here, because of the user input, there could be multiple problems, and so the result of A to D is as follows. The offset of the terminating non-digit character is put in register ESI. What does it mean is that if the input contains something like 1, 2, 3, and then A, B, C, right? So it's a mixture of digits and text. Then the offset of terminating non-digit characters, such as character A right here, is going to be placed into register ESI. Okay, so this is just something that happens to be as one of the possible outcomes right here, because if we have like an enter key instead of ABC, we're just going to convert the entire input. But other than that, there could be non-numeric input remaining in the input buffer, and then we can continue processing it based on the value of register ESI. If no input error is detected, the overflow flag OF is cleared. So notice that in our program, what we do immediately after doing this conversion right here, Ascii to double word, we check the overflow flag and we say jump if no overflow. That's what JNO stands for. This is the command, and this is called anonymous label. Anonymous label actually looks like this: two @ with a colon. And so these are anonymous labels, essentially labels that have no specific name. And the way it works, that to anonymous labels you can jump forward and backwards. So you can just jump forward right here, and so forward means jumping right here. If you say jump at B, which is backwards, then you're jumping to the anonymous label, which happens to be somewhere earlier in our code. So the outcome is that if overflow flag, if no error, then overflow flag is cleared, and that's why we say everything is okay, let's continue the program. So we're jumping from here to here if everything is okay. If we did not jump, it means that the overflow flag was actually set. So that means that conversion of our Ascii input to double word has failed, because very likely because the user bad format input. And here we print the error message. So this overflow is something like this: bad input number, please try again. So this is what we're going to print right here, and then end of line, and then we're just going to jump back to the prompt and let the user to redo this work. Okay, so let's test this portion of the program. And remember, so I made the change from A to I to A to D right here. Okay, so this is an example of a change that I made to be able to experiment with A to D. So primarily we're just going to focus on 32-bit integers, and so that's why these conversions are like the most usable type of code that we can do with these macros. All right, so let's try this program. I'm going to build it. Okay, so we build this program, it builds okay. Now I'm going to start running it, and I will place a breakpoint on this line. Okay, so I'm going to just try to do what we just discussed with the central attention given to this A to D, Ascii to double word, or basically Ascii to a 32-bit integer. All right, so let's get started. I'm going to just say debug, start debugging, or you can press F5. So first it's asking me to input 10 characters of text. Up to 10 characters of text, I'm just going to enter ABC. Okay, so that tells me that, okay, you entered ABC, and then it echoes back how many characters I actually typed. So ABC indeed matches the 3 characters. Please enter an integer, so we type ABC again, which of course should cause A to D to fail. It's not going to be able to convert this to an integer, and therefore the overflow flag will be set and will not be conditionally jumping to the next step in our program. So I'm just going to say ABC, and here it prints this prompt right here, says bad number, please try again, and jumps right back after printing new line right here, right? It jumps right back to the previous anonymous label, and we say please enter an integer again. So if I enter a correct integer like 1, 2, 3, then we're moving forward, and now we just stopped on this next breakpoint, which is demonstrating how to convert 16-bit signed integer to a string. Well, anyways, so this is now everything worked correctly, and the outcome of A to D, which was this time successful, is that if no error input detected, the result is set in register EAX. Okay, so the result is stored in register EAX. In addition to EAX, if the result is negative, the sign flag will be set. If we just entered 0, the 0 flag will be set. The parity flag also reflects the parity of the number. We'll see example of the parity flag in the future. The parity flag is also set. The carry flag is cleared as a result of executing Ascii to double word. Direction flag is unchanged. So these are just the ways of manipulate all the flags according to the result of A to D. So remember, the result comes out, successful result will come out in register EAX. If input error did take place, there was something wrong, the overflow flag is set to 1 and EX register will contain 0. That's just the way this macro is programmed. So this is very important macro because we can accept user input and then accepting it as an integer we can convert to an internal 2's complement value. So this is important macro for our communication with the user. Basically input followed by conversion of that input to a double word integer value. So input occurs if the source has no digits or is out of the range. All right, so this is really the range for 32-bit values. So we try to enter this number right here, right? If I restart, if I stop debugging, and if I run this program again by pressing F5, and I enter some characters, whatever, this first thing is that just to enter some characters, and then please enter an integer, and attempt to enter this largest positive value, and of course I have to just get rid of these commas for the proper format. And how about I change it to a larger number? So now it's 3 billion. And in enter you can see that this is now the bad number. So this is the bad number not because there is a problem with numeric format, but it's because it's impossible to convert this 3 billion to a positive integer in 2's complement format. Okay, so that just makes sense. That's the example of when the input error occurs when the source has no digits or is out of range. So this is an example where it's out of range.